Okay. All right, sorry for the delay. Just one administrative note. We need to get teams formed. So if you would please use the notice board to use the hash mark board tag. Actually, I think I have these directions in the lecture someplace. Let me just see here. Right, so, right. So, please post a request on under hashmark group, under the group tag, so that I can see all of the requests easily. And if you see, if you see somebody else has posted, talk to them, email, something like that. Post your email so that you can contact them, so that people can contact you. And then what's going to happen? Oh, and then keep that up to date. In other words, edit the message, take your name off when you found a group. And anyone who remains sometime in the middle of this week, I'm going to start assigning randomly of orphans to groups. So naturally, it's in your interest to get and naturally I'm going to preferentially assign to smaller groups. So it's in your interest to get yourselves organized. It's in the interest of people in groups to be proactive in selecting members. So let's get that done so that we can get on with the projects. But in the meantime, I'm going to go back to where we were. Okay, so first, administrative questions or any other questions that we might have. I didn't see. Now I have an open invitation to people. Send me ahead of time questions that you'd like to see on, outstanding questions that you think maybe won't get answered in lecture in the normal course of material, but something about something I've already covered or anything like that. Send me a note ahead of time so that I can work it. Maybe I can work it into the lecture rather than simply respond once and then respond to everybody else who has the same question and who doesn't read the notice board with the answers on them. So that would be kind of useful and gives me a chance to see what's causing confusion and to try to do something about it. Okay, in that case, yes. Oh, am I going to change the office hours? Is there any, does anyone really care deeply that I maintain my current Thursday office hours? Anyone who has a deep moral or emotional commitment to that particular time, even though it's on top of one of the discussion sections? Okay, well, I'll probably change it. I'll make some sort of announcement. All right. Good. Yes. Oh, the light. I don't have to know a lot about the light. Let's see now. Which one of these? Oh, wait. First I have to do this, don't I? Then I have to do... No. No. Absolutely not. It's being stubborn. Oh, here it is. That's right. I forgot. There we go. Is that better? Better? Worse? Yes? Okay. All right, so we already did this. I should say this has caused some people some problems, this particular one. Log messages. It's a bad habit, actually, to do this, to do what I've shown you up there, to put the message in the, actually on the line, because generally it really ought to be a better message, more extensive. So we have it set up on the instructional machines that it will try to fire up an editor. You can specify the editor and put that into your local profile, in fact. And I think several respondents have indicated how to do that in the notice board. By default, I just have it sent to any running Emacs. Now, unfortunately, this means that if you're at home and you forget to do this, and you log into the instructional servers, it will try to start something up on the instructional servers and give you a rather obtuse error message. So make sure that you get that working, because this is the sort of thing that in a real project, for example, this is an open source project, and this contains an example of from the days when GDB was still using Subversion. It now uses Git. In those days, how these log messages looked, they sort of looked the same, but with a little bit different boilerplate. So this particular thing, for example, there are a few lines at the beginning. This shows you a log message that you can then retrieve using the svn log command, which is a very useful command for finding out what revisions what snapshots have been saved, what snapshot was the ancestor of the one that you're currently on, and so forth. Was the parent of the one you're currently on. And it also contains the log message, the commit message that went along with it. So in this particular case, this is a commit message that has what we call a change log in it. So it has a little summary. There's a little summary sentence up there about what the general idea of this particular change was, and then a summary of the changes to each file, where we say it's quite brief and technical, but nevertheless it gives you some idea of what's going on. So this is quite a bit of information that you can then use later when you're trying to find out what revision was it where I did such and such, and that can be kind of useful. And it also contains the name of the person who committed this particular change, so that you can tell who it is, whom to call, which among your partners is the culprit for a particular change to the software. So this is all very useful. When I showed you in the sort of model of what's going on, how you get a copy of the most recent version of your project, the way that you do that is you use this command, and that pulls in and attempts to merge in any changes that have been made since the last time that you had something to do with the repository. And when that happens, you will occasionally have cases where the changes that you've made and the changes that other people have made overlap. And when that happens, you get a report that that a certain merge didn't work, and you are then able to do something about it. So this is what happens when I think this is the message you get when you commit. It tells you the things that have been updated, what has been added, what's been deleted, and then it also tells you this is something that had that non-overlapping modifications from the repository that was overlapped with one of your files, and this tells you that something, and this tells you that there were conflicts, that you had conflicts on a particular file, and in fact, this is what you get. This is what you get from also, I think, what you get from SVN status. So you can then find out where these conflicts occur. You then edit the file, and in the file you'll see that it has helpfully left you with these little tags that tell you what the overlap is. So it tells you what you did above the equal signs, and it tells you what was in the repository below the equal signs, and this will appear somewhere in your file. So you go in and you look at that change and you say, how do I reconcile these two? And it's up to you to do the necessary editing. When you're finished, this is actually the old way of doing it. You have to tell Subversion that you have finished. You save the file and you tell it, yes, I have finished. This is now resolved by either of these two means. The second one is the modern and preferred form, although more verbose. And then you commit. At this point, you commit the file, and now your changes merged with whatever came in go back out. You generally do not want to proceed much further without committing whenever you do an update that causes a merge, because unless you're working on your own stuff and you're not ready to do it, but you want to be a little bit careful. You want to be careful to get things saved at that point. Otherwise, you'll get confused with the changes that were made from the repository and the changes that you made to reconcile the repository and the changes you made later, and it all gets mixed up. And so it's better to committing early and often is generally a good thing. If you fail to resolve anything, then the other thing that will happen is if you commit and you have failed to resolve something, Subversion will say, this dispute has not been resolved yet. I will make no commitments. All right, now another concept that's prevalent throughout version control, all very different versions, all different version control systems, and is handled differently in each, is the general concept of a branch or a tag. So the idea, it's called a branch because if you think about the sequence of snapshots, of revisions, then and you think of there being a link from each revision to the one it came from the one that preceded it and that it was derived from, then a branch makes the thing look like a tree. So you get little limbs going off to the side that are not part of the main trunk. Use that term. And so these things are very useful to allow you to both use a repository and at the same time not interfere with what other people are doing. So you can go off and fiddle with something provisionally, or you can fiddle with something and get it into commit versions that are in a broken state because you're working on them, and keep them completely separate from what's supposed to be the working version. So here is an example. It's not in your team repository. The sort of traditional way of doing this is in your team repository. You could create a subdirectory called branches, and then copy the current state of the project that you're working on into that new repository and give it some name. So Bob's Project 1. And what that does is it takes the current state of the repository, makes a copy, a snapshot that's identical to it, but it's in a separate part of the repository. It's like a separate directory, a complete new copy of the project, in effect, which you can then check out and work on. And anything you do and anything you commit from that will have no effect on the main part of the project. So. And this doesn't waste space or anything because that copy from the main project is internally handled very easy. It's basically the internal machinery says, oh, this is a copy of that, so I won't bother to save it again. You just go and find the main project and put that out. So this is actually very nice. It's a nice way of doing this in one way at least, in that there's nothing new that's going on. This is not a new mechanism. In most version control systems, branches are a separate concept. In Subversion, they turn out not to be, and that has both its strengths and its drawbacks. Yes. You mean copying it with using a Unix command, an ordinary Unix utility command? Okay, well, that's an interesting question. This is somewhat of a side question. So the question is, suppose that I have a directory under version control. Let's call it foo, and I want to make a copy of this directory and give it another name, like bar. So the way that we've been doing this is you can say svn copy foo to bar, and that will copy all the files and set everything up to be committed back into the repository. You can also do a copy directly in the repository, which sort of does the commit in the same step. And the question is, could you also just do I would use probably rsync or something like that, to copy foo into bar by hand, and then say svn add bar, which which will then add it to the repository. And the answer is, yes, that will do the same thing. The thing it loses is that the log will lose track of the fact that bar comes from foo because you haven't done it. So if you're interested in looking at the trace of, it will get confusing because things will suddenly start in the middle of nowhere. That will work, but there is one caveat, which is that if you copy from foo, if you copy the hidden directories, the .svn directories into bar and then try to add it, it will tell you it's already under version control, even though it isn't really, and it will get totally confused. So if you're going to do things that way, and I'm not exactly sure why you would want to, but there are cases, I suppose. So I mentioned rsync, rsync. I should probably post some extra documentation on that. Very useful command. It's for shipping whole directory structures or individual files from copying them within a computer or sending them over the internet. Very handy. And it has parameters for saying don't copy any of the files that look like this. So that gives you a way of doing that particular thing. Did you have a particular reason why you wanted to do it that way rather than? No, okay. All right, that's fine. Curious is good. Yeah.
If you have a branch, what if we get confused which project one we're working on? Is there a branch? We were stupid and name the directories differently.
Okay.
How do we find out where we're at?
SVN info is your friend. In that case, you will find that SVN info in the direct. So the question, I'm sorry, for the benefit of anyone listening separately, the question is, how do I, if I make a copy of a branch and don't give it a new name or something like that, or I put it into a local directory that doesn't have a new name, how do I know what it comes from? And the answer is, in that directory, if you execute svn info, or if you say svn info and give it that directory name, it will tell you what thing in the repository it refers to. And that's, by the way, that's how you can tell. Whenever you get the message, access denied, when you try to commit something, do an svn info. And I bet you dollars to donuts, the reason will turn out is that svn info will tell you that the URL that you're taking this from is, in fact, the staff repository because you did a checkout instead of a copy or something like that. It's a very useful command. Okay, so let's see what we've got here. A tag, same as a branch, except, so it's another copy. And it's just that with a tag, which you've been using, of course, for homework, a tag, you don't generally, the custom is you don't change it. You don't, once you've created this copy, you don't go back and modify it because it's basically you're saying this is a particular version that has such and such a significance. It's a way of naming a particular version of the software. And that's, so people will do things. People will use these things for releases, for example. You'll have a directory for every release. So GDB release 5.3, 6.4, 7.2, and so forth. And this is very useful. You can also use it for when you create a branch. A very common thing to do is to drop a tag that says that records where you made the branch, so that when the time comes to merge your changes from the branch into the main line. You know what the range of versions, you can symbolically refer to the range of versions that you have to merge. Okay. So here's how one can turn in work. These are, you've already done a lot of these things, so I'll just go through this very quickly. You can copy, Subversion allows you to copy make a command that applies just to the repository. So since we have abbreviated the URL of your repository like this, this particular command says, go to the repository, don't change any of my files, go to the repository and make this copy. And it will, what I haven't shown you is that you will be asked for a commit message at that point. Another possibility is, then these are just, I'm sorry, this is just Unix shell script hacking, these other two things, taking advantage of some of the abbreviations. Teams, exactly the same thing, no difference. Now, another thing you can do with revision control is you can compare things. You can compare one revision with another. You can compare revision 9 with revision 10, for example. You can you can compare two different repositories or two different directories in your repository. Like, for example, here I am comparing Bob's Project 1 branch with revision 100 of the trunk. So you can do that, and this will give you a complete listing with the files, where the differences are, and all that sort of thing. So finally, now this is a sort of an esoteric topic in a sense, because it's the most problematic. It's one of the things that two different people have changed independently, basically, so that happens automatically when you update. But in addition, if you're on a branch, for example, and it's time to take that branch and merge in changes that either other people have made into your branch or changes that you've made in your branch into the trunk, then you have to start using this fancy command, the svn merge command, which says basically, so I go into the directory, a working directory where I've checked out whatever the branch is I want to merge into. For example, if I want to merge merge maybe my branch into your team's current trunk or something like that. You go into a directory that contains your team's current trunk. And then you say, I want to merge all the changes between these two places, these two things, into this directory that I'm in now. So, for example, I can change I can do something like this. I can go into, I can look at two tagged revisions, V1 and V2. In my team repository, and I can merge all of those changes into whatever my current working directory is. And this is the command that will do that. And it will give you the same thing that happens when you update. It'll say, okay, I added this file, I deleted this file, I merged these two files together, oops, there was a conflict here, and you have to do the same thing that you did with update. I'm not going to go into any more detail because until you have experienced this, until you've tried going through this, nothing I say is going to make a great deal of sense. So consider this a great adventure that lies ahead of you, at least if your partners are energetic. If you're the only one in the team who does any work, well then none of this information is of any interest to you, but I hope that doesn't happen. And then finally, we have a few commands. We have various commands for interrogating. So you can ask, for example, ls command, like the ls command in Unix, will list things in the repository. So you can ask, go to the repository, what things are in the tags directory? I can look at a particular file and ask all of the log messages that were committed, that correspond to changes to that file. I can ask with -v verbose, I can ask what are all the changes to that file and give me all those log messages and also give me some more information about those changes. So I've said commit early and often. I mean it. This is not like marriage, okay? It's okay to commit. It doesn't, right? It's okay to commit as often as you want. You won't make a mistake. You generally won't make a mistake. And when you mess up, when something gets messed up, and so that you can't get the thing to work anymore, that almost never means that the repository is messed up. It means that your files are messed up. And that's good because that means that you can go back and you can get the last clean, you can still get the last clean version out of the repository. You could, if necessary, destroy all of your working files and still recover what's in the repository, assuming, of course, that you've been committing often enough that there isn't a huge amount of work that you would throw away that way. Or if you've got a completely messed up directory, you can shunt it to one side, do a simple Unix command and move it to one side, check out a clean version of the file, and then by hand go and modify remodify the files that should be modified and commit the result, and now you have something that's clean and working. But as I say, in order for this to work, you have to commit early and often. All right. So this is a practical lecture split over two on version control. It's just what I've said to you so far are just words. When you use this stuff, it will become internalized. You'll understand it better. Now, some of you, I understand, are using Git, so you have an extra step because since we talk SVN here, that means that you're going to have to be careful to use that Git SVN bridge to change your Git check-ins or Git commits into SVN commits, and so you're on your own. Well, maybe we'll help you occasionally, but that's an extra step. You have brought it on yourself. Good for you, but be it on your head. Okay? So I applaud your initiative, and it's very useful because a lot of open source projects these days are moving to it. So. Okay, questions on this? Yes. Are you required to update? All right, that's an interesting question. So the question is, in our examples, we keep recommending that you update after you commit, and this is a bit controversial. SVN has this peculiar notion that when you commit something, the working directory still records the last time that you still records the last time you did an update as the version that you currently have in memory, and the result is that you can get these peculiar mixtures in which you have some files from one version with some files from another. You're missing the log information from later versions is missing from your working version, and so forth. Now, there are uses for this, I'm told. There are uses for this. I usually find it confusing, and I usually find that it is, and I almost always find that it's confusing for students. So my recommendation is, after you do a commit, do an immediate assuming the commit is successful, do an immediate update. The result will be that you and the repository at that point will be in sync with each other, and that's probably, and for the purposes of this class, that's probably the right thing to do. So. Okay, good. Let's take a break, and then we will get on to the next big topic, which is before the project, which is parsing. Okay, let's start up again. Thank you. So just a reminder of how we're progressing. We've finished, well, for the most part, breaking source code up into convenient chunks and filtering out one source of error. And now we're going on to something called parsing. The idea behind parsing being that we will examine the grammaticals and verify the grammatical structure of whatever it is that we're reading. And we will allow that grammatical structure, this is the important thing really, we will allow that grammatical structure to drive a translation from the source to the stream of tokens into something, into some convenient form, which at the moment I'm calling which we'll just call AST here and define in a moment, or define at some point in the near future. Now we've already seen this by dint of the fact that I sort of experimentally introduced this concept early on, but in the context of tokens and lexical analysis. But let's do it again. So BNF, Backus-Naur form. And again, this is a pattern matching language. We have rules of that form there. X goes to a bunch of things where where we call X, there are lots of, you can sound very esoteric. We can call it a meta variable. Actually, I don't know that a hyphen is called for. Anyway, you can call it a meta variable. You call it a non-terminal, so-called because it's not the end of the line. It stands for something else. And we might write, so when you have an empty production, you can simply write X with no alphas after it, or you can write X colon epsilon sometimes just to drive home that it's empty. In ASCII, I generally just put a comment empty there. And again, this rule means that X, which is a language, a set of strings, may be formed from one from alpha 1, one from alpha 2, and so forth, where all of those are languages. So it's just like concatenation in a regular expression. So if I then finally give you, if I finally designate one of these things as the start symbol, that is to say the thing that describes whatever the language that the whole grammar is supposed to describe, then I have what's called a context-free grammar. It's called context-free because I am allowed to apply any of these rules in any context. In other words, if I've got an X, I can always turn it into an alpha 1, alpha 2, alpha n, regardless of what's around the X. So the context, it's context-free. It's independent of context. Now, in the notes you will find that we talk about something called a derivation. So this is simply a demonstration, if you will, proof that in fact a certain sentence is in a certain string of terminal symbols is in the language that's described by a certain non-terminal symbol. Generally, for an entire program, that would be the start symbol. So we write this demonstration as a sequence of, or we can write this thing as a sequence of strings of symbols, which I've written as alpha. So we can start with a start symbol. To answer the question, is the thing at the right there, that's the tau 1 through tau k, is that in fact a sentence or a sentence or a phrase in the language denoted by A, the non-terminal symbol A. So to prove that it is, if it is, I apply a bunch of rules to get a sequence of sequences of symbols, such that the last one is the the string of terminal symbols that I'm looking for, that I'm trying to prove is in the language. And if I can do that, then I have demonstrated that sequence of terminal symbols, that phrase, is in the language. And I've also done more because I've shown why it's in the language. This is just like math, where it's not just the end statement of the proof that's important. The proof itself is important. In this case, the proof turns out to be rather important. But don't worry, I call it a proof, but it really won't feel like that when you're doing this. So those of the math phobic among you can take heart. So but for the moment, I will continue to confound you with these Greek phrases here, or semi-Greek phrases. So one step in this path, in this derivation, consists of finding a non-terminal symbol somewhere among the first bunch of symbols, one bunch of symbols, applying one of the rules in the grammar to it to get another bunch of symbols, and then inserting that in the middle. So, for example, I have alpha 1 through alpha b, alpha m plus 1, and so forth. I say, okay, well, I have a b here, and I have a rule. B goes to beta 1 through beta p. So I will just change the b into beta 1 through beta p, and that gives me one step in this derivation. So if I can go do a sequence of those steps and get to the terminal symbols, then I have succeeded. So a little bit of notation. It's rather than having to write out every single time A goes to bunch of symbols, goes to bunch of symbols, dot, 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 goes to bunch, oh, that's terrible. We'll just use this notation here, which says that if phi1 and phi2 are sentential forms, that is, sequences of symbols like the things between the arrows up above, then phi1 arrow star phi2, that means that either phi1 and phi2 are the same already, or with some number of steps, I can get from some number of steps, 0 or more, I can get to phi to the second phi, phi2. And plus means that it takes at least one step. In other words, they're not the same. It takes at least one step to get from one to the other. So, in other words, in summary, if S is the start symbol of a certain language with grammar G, then a certain string of terminals is in the language of G, is in the set described by G, if you can derive it from S, according to the grammar. So that's and that's sort of the subject of the next several lectures and so forth, and of the first project, to get that to happen. And in the process of doing that translation, to produce derivation, to produce a translation of the original sentence. So here's an example. We have a very simple grammar that's sort of vaguely arithmetic. So it allows you to do have parenthesized to have function calls, divisions, and ultimately at the lowest level you can have optionally signed identifiers. So S is intended to be an optional sign. It can either be plus or minus. And alternatively, we can write it as you see on the right, but we've already been through all of that. So I'd like to show that this string here, negative ID divided by ID divided by ID, the quantity, is in fact in the language. You look at it and you say, well, obviously it is. I mean, good grief. I mean, what are you asking me here? The first E obviously matches a sign and followed by an ID, and the second E obviously matches, we're looking at Rule 3, and the second E matches another instance of Rule 3, and what's the problem? But let's just see that formally. So here's one way to do it. I start with E, assuming that E is the start symbol here. I apply rule number 3 to get me to E/E. Then, so that means, so I take the E part and I do E/E. So now I apply, now I have two non-terminal symbols in this second sentential form, E and then another E, and then there's a terminal symbol, slash, between them. So I've produced one of the slashes in the output in ID/ID last parenthesis ID. Tell me which of the two slashes in that final in the thing that I'm trying to derive, which of those two slashes do you think this slash is? Yeah, the far left one, right? How do you know? Uh-huh. Right. So, I mean, basically, I can't. There's no way that I could match that slash to the second slash without doing something. Well, without taking up too much of the having unbalanced expression, basically. Okay, so now I have a choice. I have two E's. I can change either one. I'm going to change the first one. I'm going to choose rule number 1 to change that into an SID. Okay, now I have two then I will have two non-terminal symbols, S and E. I'll choose the first one and change that into a minus. In fact, every step here, I'm going to arbitrarily choose the first non-terminal symbol. And you see the sequence. We go from SID to minus ID. Then we start working on. Then there's only one non-terminal, so we have to work on that. So we choose which thing we're going to do. So we'll use rule number 2 this time, and that's how we get the S parenthesis E thing. However, this time S is just empty, so that goes. So in the next step, we apply rule 4 and turn the S into the empty string, nothing. So we're now on the second line. And then we just keep going. E turns into E/E again, and we get the SID and the SID, and finally we end up at this last thing, which is the terminal string we were looking for, proving that in fact that string is indeed an E. So this is an example of a derivation. Because we always chose the leftmost symbol, it's called a leftmost derivation. And the significance of that we will get into. Okay, so that's as much as we have time for today, and I'll see you next time.